Welcome to the Stormsurf video surf forecast for the week starting Sunday, July 17th. First up, we take a look at significant wave heights for the South Pacific Ocean, and just like last week, we see not a whole lot going on. The good news is the pattern is expected to change long term. Let's get into the details. We'll take a quick look at what's happened over the past week, and specifically a small gale right here that developed on Monday, and we'll watch this as it sort of lifted north starting actually, it was almost Tuesday morning. Small area 30-foot seas, went to about 18Z on Tuesday, and then started fading out and was gone. That should make a small pulse of southerly, south-southwest swell for California and south swell for Hawaii. Not a lot of size, but just a little bit to provide something rideable through the work week. And then also notice on Monday, this little area of fetch here, most of this 30-foot seas heading southeast, and then watch this, also another small fetch develops here, basically outside of the California swell window, about 117 here relative to Southern California, but just enough to maybe push some very south-angled swell into Southern California for late in the work week into the weekend. And then after that, you can just see nothing happens in the California or Hawaii swell window. And let's just get it right up to current time. Right there you go. And this is where we're at. So as usual, we'll start out here with jet stream level winds. What we're looking for is a trough. That is a sort of a dip in the jet stream. Not really a dip, a surge to the north in the jet stream. That would help create a clockwise flow in the southern hemisphere, which is the equivalent of low pressure down at the surface also, and that would help to create winds. Winds, of course, generate seas. Seas, when they move away from the fetch area, generate swell, and swell eventually makes surf. Currently, what we have right now is a very split jet stream. Southern branch, the running over Antarctic ice, the ice line is anywhere from about 62, 63 over here down to maybe 65. This is about the seasonal peak of maximum ice down here. Then the northern branch is way up here running around 30. But it's this southern branch that really helps to support gale development. And as you see with this split jet, just a big ridge pushing down here, this supports high pressure in between the two streams of the jet and is not at all conducive to storm development. This split in the jet, we believe, is attributable to the inactive phase of the MJO, which is developing at this point in time. But we watch here, we're into Tuesday. Notice this ridge just continues, but it starts weakening over here come about Wednesday. And as we get into, say, Thursday, there's some sense that the ridge is gone. You almost have something that starts to look like a trough here, but not really. But then we get into, let's say, Friday night, and then we have, again, you got this little bit of a ridge trying to go underneath it, but there's a bit of a more defined trough starting to develop here into Saturday. And then Sunday, not a lot of wind supporting it, though. It's kind of hard to say, but the pattern definitely looks better than what it has been the past week. So there's some hope for gale development in this region. Let's go down to the surface. Next, we'll take a look at surface level winds. We're having some pressure, some issues with the chart that shows actually surface pressure and wind, so we'll just default to this one. That issue should clear itself up the next run of the model. So we're looking for some sort of fetch in excess of about 40 knots pushing to the northeast here. Clearly you don't see it. You see fetch pushing south into Antarctica, and again, here's a little bit 30-knot winds, but barely in the California swell window and of no real interest to anybody. But notice here you get into about Tuesday, and here's 40, 45-knot winds trying to push under New Zealand. They fade pretty quickly, but there's some hope there, and then we'll roll out. And here we go, little area 55-knot winds. Now this is, for the most part, shadowed, but maybe not so much once you get into Saturday, a broader area of 40-knot winds building to 45 knots and lifting up under New Zealand. Not particularly great looking, but at least there's some hope over in this area. Otherwise, not a whole lot going on. Let's go take a look at the wave model charts. So here we go, significant wave heights for the South Pacific Ocean, 18Z Sunday, and as we said before, not a whole lot happening. Roll this out, and you notice we start getting some activity under Tasmania come Tuesday, and the California swell window, this is almost in it, and notice there, what is that, 32, 4, 36, 37-foot seas, trying to sneak under New Zealand. If that were to happen into Wednesday, that would produce a small pulse of swell. I mean, it's a long ways away from the U.S. West Coast, and even a little bit here relative to Hawaii, assuming this all happens as forecast. And that one sort of fades out. Little tiny bit there, but not much. And then another one is supposed to develop late on Friday into Saturday. Now, the issue is you got to get pretty much down here around 55 to get into the California swell window. This is a bit to the north, but once it starts easing out into here, then it's exposed. And you see little bits of seas, so perhaps maybe two small swells, long distance away. This is about 6,500 nautical miles out, unshadowed relative to California by Tahiti. Hawaii, the bigger issue is just New Zealand sitting smack dab in the middle of the way. But actually, if you go back here, when it's down in this region, you can get swell relative to Hawaii, but it gets pretty graded out here by Fiji, and also there was another one back here. We'll see what that does. And that same thing. So really, Fiji and New Zealand are the places that are going to score, and of course Tasmania. California and Hawaii get remnant energy. And a quick look at the tropics. Relative to California, not a whole lot going on. The remnants of Celia, which was a hurricane down to below depression status now, is poised to track west, and that is north of Hawaii, over the next day or two. Not a whole lot going on with that. Maybe good for wind swell for northeast-facing shores. And then Darby behind that, and Estelle behind that. Let's go look into the details. So first up, taking a look at Darby. So back here, roughly around here, Friday 18Z, it peaked out with 100-knot winds, all moving due to the west. Very little energy expected to radiate into California. Now this position right here is about 122 west, 123. Let's say it was actually off the chart here. That would put it just barely in the central to North California swell window and past Southern California. But again, in tropical systems, winds, of course, rotate counterclockwise, and if it's traveling to the west, that's where the majority of the energy is heading, or off towards Hawaii, specifically the Big Island and maybe the eastern tip of Maui. Everything else is pretty shadowed, and this is a long ways away. What is that, 30, so roughly, let's say 1,600 nautical miles away or so. Anyway, current position right here, still not that much closer, 80-knot winds, a slow fade expected, and then it's down to basically depression status by the 22nd, and likely to pass somewhere south of the Big Island. Still good for some level of easterly swell, probably in the 15-second period range, something like that, for the exposed islands on the east shore. And here's the latest satellite image of Darby. Still a little bit of a obscured eye here, but a good circulation, symmetrical, a well-formed storm, not huge in coverage, but still well-formed just the same. And this whole spat of tropical systems, there's been a bunch of them right in a row, is all attributable to the active phase of the MJO over the tropics, pushing east, and for the most part anywhere from the date line over towards south of California, and that is fueling certainly this system and a few before it and a few to come after. Next up is Estelle, current position right here south of Socorro, or south-southwest of Cabo San Lucas by about 450 nautical miles. Again, it's still on this it's a west-northwest track here. Current wind 60 knots, so it's not even hurricane force yet, but expected to reach hurricane force, so probably right around now to this evening, and holding, and then to the 19th, so somewhere out around here. Again, maybe there's a little chance for small sideband swell radiating up into Southern California, but most of this energy is going to be pushing off to the west. The system goes further north than the storms before it and fades out on the 22nd, again down at minimal tropical storm strength. Not a whole lot expected from this. And the visible satellite image, I guess the core of this storm is somewhere right around here. You can see banding and some of it trying to work its way in. Central dense overcast, a little bit north of somewhere where the center would be, or maybe northeast. This system's still getting organized. Not nearly as impressive as Darby, but we'll see what happens. Then let's take a look long term. What's going on with the MJO and, of course, La Nina. First up, we take a look at winds, specifically in the Kelvin wave generation area. That area running from about 135 east out to about 170 west and 5 degrees north and south of the equator. This is where you look for the presence of the active phase of the MJO. We see light winds in this region right now, where easterly winds are everywhere east of there. Pretty typical of La Nina, though if it were a strong La Nina, you would expect to see easterly winds here as well. These are actual winds at the surface based on the TAO buoy array. Bits of El Nino still holding on in the atmosphere, either that or the MJO suppressing what would normally be easterly trades in this area. Looking at anomalies, differences in normal for this time of year, this is a pretty normal pattern, not easterly or westerly anomalies, just neutral in this area. And pretty much the same in the Kelvin wave generation area. I'm ignoring the fact that there's cooler than normal water here in this area, but that is typical of La Nina. Another way to look at winds on this chart here, 850 millibar, that's up about 4,400 feet in the atmosphere. Date lines right here. This is the whole planet on one chart. Kelvin wave generation area is roughly right in between these two. Back in the end of June, inactive phase of the MJO started setting up. Easterly anomalies, that's what these blues are. And then things have lightened up, some sort of we wouldn't even really call them westerly anomalies, just neutral winds pretty much through July, attributable to the active phase of the MJO. That's fading out now. And as of the 17th July, the next inactive phase of the MJO is set to take hold for the next week here in the Kelvin wave generation area. Westerly anomalies right in here. This is, actually out, so all those hurricanes were coming from, somewhere right around here, this area, and westerly anomalies perhaps helped to fuel that. Next, we look at the setup for the MJO. This is outgoing long-wave radiation. Yellows and oranges suggest more sunlight reflectivity off the ocean's surface, suggestive of high pressure. And the inactive phase of the MJO, active phase here in the Indian Ocean, but also remnant active activity here in the tropics. The very last lingering bits of it that is likely helping to fuel the tropical systems we just looked at. Anyway, per the statistic model for the next 2 weeks, inactive phase expected to take hold of the West Pacific, then fade out. Per the dynamic model, pretty much the same thing, maybe last a little bit longer. But if you look at the whole picture, a rather weak MJO pattern. Next up, phase diagrams. These charts help identify where the active phase of the MJO is. Assume you're looking down on the North Pole of our planet. You move, the active phase moves from the Indian Ocean over the maritime continent, consider that like Bali, that area, over across the date line into the West Pacific, into the U.S., over the Atlantic, into Africa, and then back to the Indian Ocean. So it rotates counterclockwise along the chart. The big dot is where the active phase of the MJO is, so somewhere in the far east Indian Ocean. If it's near this circle, it's considered extremely weak, and the green path is the forecast track, so it's weak and forecast to collapse per the ECMF model. The GEFS model, which is basically the ensemble GFS, basically saying the same thing. Maybe it'll hang a little bit longer here in the eastern Indian Ocean and then collapse again. Next up, we take a look at the CFS version 2 model. Again, Kelvin wave generation area from, let's say, 130 east to about the date line right here. This chart's in reverse. That is, past history is down at the bottom. We're going to overlay the MJO, though you can kind of see it. We'll look at this. You can see westerly anomalies. Yellows are westerly anomalies in the Kelvin wave generation area. They're all but gone now, suggesting that the active phase of the MJO is fading out, moving east. Southern California is over here. This is where it would be strongest, right in this area. And maybe you have another week of that, and then a very, very weak inactive phase of the MJO is forecast in the Kelvin wave generation area. Easterly anomalies, weak easterly anomalies in patches. And that continues into, well, here we go, into probably end of August. Let's see, this active phase ends about, in the next 3 to 4 days. Then we have basically a month of the inactive phase of the MJO. The active phase is supposed to appear again the end of August. That would be when our best shot for swell development would be. And notice westerly anomalies not, so there's 130, not even supposed to really make it into the Kelvin wave generation area. This easterly wind pattern would make one believe that La Nina is getting established. We'll take a look at the low pass filter here, and that pretty much shows it. So here's our El Nino, all but faded out by the beginning of September. Here's the developing La Nina. This is the center of max precipitation energy, upper level atmosphere, if you would say, and this is all over the Indian Ocean, pretty typical of La Nina. So this does not set us up very well for the fall. That is not to say that we will not have storms or will not have surf. It just won't be prolific like it was last year, or relatively so. Next, we take a look at subsurface temperatures in the ocean. West Pacific here, East Pacific here. If El Nino were in play, and notice we're going down depth 200 meters, 300 meters. If El Nino was in play, we'd see a lot of warm water here. Instead, all our warm water, 30 degrees Celsius, is sitting in the West Pacific. A more normal pattern. The more this warm water gets bottled up in here, the more one could say La Nina is in place, or really the cooler waters are off here, La Nina. Anyway, and that's what we're seeing, 28-degree isotherm, limited to 165 now. Last year at this time, it was stretched the whole way over here, and there was a shallow warm pool in this area. In fact, it was even over here in 2014, but it's all receding to the west now. Here is anomalies, differences. Normal for this time of year, little bit of warmer than normal water, 1 degree anomalies here in the West Pacific. Barely anything that is normal in the East Pacific. And subsurface, this is the thing. If you were looking for Kelvin waves, this is where you'd want to see them. We don't see that. These are -3 degrees above normal instead of +3 degrees above normal. So a river of cold water at depth running to the east, typical of La Nina, and some of that advecting to the surface here between about 130 and 150 or so west, so south of Hawaii. Another version of that chart, a little bit higher resolution, shows warm anomalies starting to develop in the West Pacific, cool anomalies in the East Pacific, the big cool pool south of Hawaii right here at about minus, 1, 2, 3, 4, 1, 2, 3, 3 to 4 degrees below normal. So pretty much like the other chart. Clearly, La Nina is in play. There's no hope for El Nino because there's no warm water over here to start pushing east. So the way the cycle goes is this will go for a year or 2 or 3. Warm water will continue to build here in the West Pacific. And then when the warm water gets so big here that it just can't, the ocean can't stand it anymore, then all of a sudden westerly anomalies will develop in the Kelvin wave generation area. Some of this warm water will start falling to depth, start migrating this way, and that's called a Kelvin wave. And that warm water will start building up here in the East Pacific, and then you're back into El Nino. Right now, we're clearly not there. We're on the rebound from El Nino. This warm pool over here has to recharge, build. That'll take a couple of years. In the meantime, cool water reigns supreme in the East Pacific. High-res surface water temperature anomalies. You can see cool water along Peru, which is really pretty normal. Little pockets of warm water right up against the coast, cooler, working its way off of Ecuador, over the Galapagos, and then heading off. And here's that area south of Hawaii, and the cool water at depth is gurgling up to the surface, erupting to the surface. We got a cool pool here of probably minus 1.5 degrees. Now over the entire region, it's nowhere near. These are more in the greens, which is what, a 0.5 degree or something like that. Roughly a 0.5 degree with pockets cooler here and there. And also notice pockets from El Nino of much warmer water still in place, both north and south of the equator, but 3 degrees north and south, draw the line here, the balance of the temps are now cooler than normal. So here's the water temps in the Niño 1.2 region. This is that area just right up along Ecuador, that area, a couple of degrees north and south of the equator. And since April, you can see, they've been warmer, but now they're just about neutral. But the Niño 3.4 region, the main area for monitoring El Nino and La Nina, that is from 120 west to 170 west and a couple of degrees north and south of the equator. The trend has been, from April, 1 degree above normal, slow, steady, downward trend as of today, minus a little over 0.5 degree, minus 0.635, and probably will continue to fall somewhere down around this region over the coming months. Here's the trend for the past 7 days. The blues are cooler than normal, red's warmer than normal. Notice you get these sort of pockets, these pulses, but the steady downward trend is what we're looking at, typical of La Nina. Notice there's a little bit of, we look for a mirror image sometimes over here off Africa to see what's going on. It sort of leads the pack, and so it's showing warmer here. To me, that would suggest that, and this is what has been going, this was much cooler. Let's say a week ago, the trend was saying cooler. It's starting to weaken now. That's probably synonymous with that. And even here, these are cooling or warming up some. So maybe we'll go on a break. We've been on a cool pulse, and then probably in another couple weeks, it'll resurface and get cool again, or cooler. The overview, here's the cool pool as we saw it, classic La Nina. On the equator, a couple degrees north and south in the main area, that Niño 3.4 region area we're talking about right here from 120 to 170. That's where they monitor, and that's exactly what's going on. We see cooler water here. And so La Nina is developing, not super strong at this point in time, but definitely there and not unexpected. This is normal after you have a good El Nino. The ocean rebounds the other way. It sort of overcorrects. It's too warm. Now it'll get too cold. And then somewhere 2 to 3 years out, it'll settle into just normal. Next up, we want to look at atmospheric coupling, the coupling of La Nina in the ocean and what effect it's having on the atmosphere above. So we had El Nino in 2014 and 2015. This is the Southern Oscillation Index, 30-day moving average. So the difference in pressure between Darwin and Australia, the temperature difference, pressure steadily fell north of Tahiti, typical of El Nino, and you can see you could draw a line right through this going south into about January of 2016, right around in here, when El Nino maxed out and pressure north of Tahiti on the equator bottomed out. Now you can see the trend is steadily upwards. And you can also see the pulses of the MJO, active phase, inactive. The active phase pushes pressure negative. Inactive phase supports high pressure. So it's pretty obvious, and it's obvious that we're in a massive inactive phase and that pressure has steadily risen. Really, this is less to do with the MJO and more to do with the emergence of La Nina. Looking at detailed numbers of the Southern Oscillation Index, and you can see the daily numbers, positive numbers suggest the inactive phase of the MJO, long running suggests La Nina, and you can see very little negative numbers here, except for the past, well, this was as of the 15th. It hadn't been updated in a couple days, but generally the trend is positive. 30-day running average getting more positive. It actually backed off to 2.93, but it was up to 4, somewhere in the 4 region right in here, and we expect it to go higher than that. And then the 90-day running average, good way to see the presence of El Nino, La Nina. Negative numbers suggest El Nino, and we steadily are getting more and more towards the positive range. At some point, this thing's going to go to zero, and then it'll start working positive from there. And at that point in time, you can pretty much stick a fork in it, call it done, and say El Niño's over. Our guess is that'll be sometime in the, mid-August time frame, sort of like what the low-pass filter was suggesting. It said early September, but it might be a little bit before that. But anyway, all the numbers suggesting El Niño develops itself in the ocean first, then starts influencing the atmosphere above it, then works its way up into the jet stream level. Now the opposite's going on. La Niña, we see it clearly in the ocean, not so much in the atmosphere yet, but little bit at a time will start working its way up 1,000, 2,000, 3,000 feet up into the atmosphere, and then eventually it's going to hit the jet stream and squash the jet stream, and that'll probably be in the fall. There's still, even that said, our tendency is to see hangover energy from El Niño last into about the November-December time frame. So we're not writing off the fall yet. And if things go well, it can actually help enhance precipitation over the western United States in the early phases of La Niña before El Niño is completely gone. But that is far from guaranteed. Next up is the ESPI index. Instead of measuring surface pressure, it measures precipitation north of Darwin, Australia, and north of Tahiti, two different regions. If the numbers are positive, it suggests more precipitation here. Negative, it suggests less precipitation than normal. Less precipitation is a sign of La Niña. The current value, minus 1.17. When we were in El Niño, this was plus 2 or something higher than that, so we've fallen a long ways. Rather dry conditions here in the tropics, typical of La Niña. Here's some other ways to visualize the ESPI. Here's the ESPI index. This was at its peak here in the most recent El Niño, falling off. Here's another way to look at it, just less over a shorter time period. This is the ESPI index peaking out here in the fall of 2015, starting to fall off. Here is the correlation with sea surface temperatures in the Niño 3.4 region, peaking out a little bit later. So the ESPI peaks early, about 2 to 3 months ahead of time, and then water temperatures follow. Both are heading into the negative range, and yet here is another way to look at it. Let's see if I can get this. Whoops. And here's another way to look at. Here is the ESPI index. Here is the Niño 3.4 temperature anomalies, and you can see they're both falling off. The emergence of La Niña imminent. And then finally, the sea surface temperature forecast for the Niño 3.4 region. Here we are, July. Temperatures, actually, they were about neutral, so this was overcalling it. But anyway, you get into about October. Temps forecast to bottom out about minus 0.75, maybe 0.8, holding into January, and then per this model, returning to neutral by the spring. That would be great if that were the case. And sometimes it'll do that, and then the year following it'll dip off again, though not as much the following winter, before it really returns to a neutral sort of normal condition in the Pacific Ocean. So to wrap things up, small southern hemiswell in the water for California right now, fading in Hawaii. Another little pulse forecast for midweek, nothing big. And then maybe yet another little pulse after that. But the models are not super positive, suggesting maybe a week from now, or a little less than a week, maybe by midweek we can get some energy pushing under New Zealand. But again, minimal at best. Little bit of swell radiating up towards Hawaii and the U.S. West Coast. Meantime, the inactive phase of the MJO appears to be imminent, setting up. That should continue to suppress storm development well into mid to late August or so, and then maybe a weak active pulse after that. But the reality is, La Niña taking over. Our best hope is that La Niña doesn't get too strong. It's not expected to. It's actually supposed to be a pretty moderate La Niña. So that's the good news. Not a super strong rebound from El Niño. So just we have to accept the fact that we're going to suffer for a year or two here. But long term, the data still suggests that the positive phase of the PDO, the phase of the Pacific Decadal Oscillation that supports El Nino long-term over 15 to 25 years, that still appears to be in play at the moment. So we suffer for a year or two, and then perhaps it's good times to follow. So that's it for this week. We'll do it again next week. Same time, same channel. Go get some surf. Get whatever you can. If nothing else, go grab wind swell. Make the most of it. Enjoy your time in the water. See you next week. Bye-bye.